Good morning everyone, and welcome to today's worked exam answer video. Today I'm taking a look at a GCSE question on electrolysis, and this specific question has come from an Edexcel iGCSE triple award paper, so the paper 2 paper, but all of the skills that I'm going to talk through are also applicable to the electrolysis content in the AQA specification as well. So this is a particularly tricky question because we're dealing with a solution of an ionic compound. So when we think about electrolysis, there'll be one of two scenarios. One, you will have an ionic compound which you've melted, and therefore the only ions present will be those from that molten ionic compound. Here we're dealing with an aqueous solution, and when we have an aqueous solution of an ionic compound, not only will we have the ions from the sodium chloride itself, but we'll also have the ions from the water. So one of the things that I'm really keen to get students to do when it is an electrolysis question is first of all establish, have we got a molten compound or have we got an aqueous solution of that compound? So the fact that this is an aqueous solution, as I've said, tells me that there are more ions involved. So another thing that I would suggest is making a little bit of a note as to which ions will be present in that solution. So because we're dealing with sodium chloride, we're going to have Na plus and Cl minus ions. From the water, which is what makes a solution be aqueous, we've dissolved the sodium chloride into water, we are going to have H plus and OH minus ions from our water. That's important because if we know we have a solution, we know that we're going to need to consider which of these two cations is going to move towards the cathode and which of these two anions is going to move towards the anode. Now we are given a little bit of a clue in this question in that we're told that two gases are formed. Now why is that a clue? Because sodium ions, if they were to move to the electrode, would gain an electron to make sodium, and sodium in its natural state is not a gas. Sodium being a metal, it would be a solid. So we already therefore have been given a little bit of a clue that it's not going to be the sodium cations moving to the cathode, but rather the hydrogen cations. For the other side, we haven't got so much of a clue, because if the Cl minus ions were to go to the anode, then they would become chlorine gas as Cl2 molecules. If the OH minus ions were to go to the electrode, then we would get the formation of oxygen as a gas. So we're going to have to think about that one a little bit. But like I say, we are told that two gases are formed, gas X and gas Y, as you can see there on the diagram. Then we're also told that one of the gases produces a squeaky pop when tested with a lighted splint. And there's another helpful clue that we're forming hydrogen gas, because hydrogen gas is the only one that will give us that squeaky pop when tested with a lighted splint. So we're then told to use ionic half equations to identify X and Y. And that is another reason why this is a hard question, because these ionic half equations can be really quite tricky. So I'm hoping to be able to cover quite a lot of key skills within this question. If anybody has any comments about anything that I'm about to do, as always, please ask. You can leave me a comment below this video, or you can drop me an email to missgtutoringandresources@outlook.com. Now, in terms of deciding which of the cations and which of the anions go to the electrodes in questions like this, without the clue that we were making gases and without the clue that one of them gave us that squeaky pop when tested with a lighted splint, there are rules that we can follow to work it out. So when we're thinking about cations, we're thinking about the least reactive metal or hydrogen, which I know isn't a metal, but we do put it on the reactivity series of metals for comparison, it would be the least reactive of those, which would go to the electrode, because when these cations are going to the electrode, they are going to be gaining electrons and turning back into atoms. Now, the whole reason why lots of elements will react, lose, gain electrons, or potentially share them is so that they get a full outer shell. So when they are ions, they have that full outer shell of electrons. They're not therefore going to want to gain the electron back to kind of regain that incomplete outer shell. Now, sodium is much higher on the reactivity series than hydrogen, so hydrogen would be the one that would be moving to the electrode to gain that electron. It's not that it necessarily really wants to do that, but the sodium really doesn't want to do it even more than the hydrogen. So the hydrogen will be formed as one of these two gases here. In terms of the anions, we need to think about it in terms of how easy it is for these negatively charged ions to lose electrons. So how easy is it for them to be oxidized? And in terms of the ruling, it goes as follows. If you have a halide ion, so an ion of a group 7 halogen atom, so fluoride ions, chloride ions, bromide ions, or iodide ions, they will always take priority and they will always move to the electrode to be oxidized, because they are the ones that want to be oxidized the most by losing electrons. Then it will be your hydroxide ions, and after that you won't need to worry, because if you have an aqueous solution you will always have hydroxide ions. So if you don't have a halide ion, you'll definitely have a hydroxide ion. So those are the two options that you will need to be familiar with. This half equation is not one that you can work out in the way that I'm going to show for the H plus and the Cl minus, so that's a half equation I would suggest you learn. And if you're not sure what that is, again, ask in the comments please. So we're going to get hydrogen from these H plus ions, and we're going to get chlorine gas, from these Cl minus ions. But how are we going to know which gas is which? Now, that will come down to which of the ions wants to gain electrons from the solution, and which of the ions will be losing electrons to the electrodes, as it were. So these inert electrodes are where oxidation and reduction will occur, where electrons will be lost or where electrons will be gained. So the ions will either be giving their electrons to the electrodes, or they will be picking up electrons from the electrodes. So in terms of identifying gas X and gas Y, it might actually be more helpful for us to write the half equations first to see what's going on with the electrons, so that we can then see which is gaining them, which is losing them, and then use the charges here to help us work out which gas is which. Okay, so when it comes to writing half equations for electrolysis, we're always going from ions to atoms. So we have got the H plus ions, and we've got the Cl minus ions, and they both want to become atoms. So a H plus ion will become a H atom, and a Cl minus ion will become a Cl atom. Now these examples are both, again, even trickier than some that you might have to do, because we also need to, once we've kind of thought this bit through, recognise that these are both diatomic gases. So we will make hydrogen atoms, but the hydrogen atoms will want to then bond together in pairs to give them that full outer shell. So we don't just make hydrogen atoms on their own, we make hydrogen molecules as H2. And it's the same for the chlorine atoms. They want to be bonded as pairs to get that full outer shell. So that would form Cl2 molecules there as well. That makes it trickier because now we've got to also balance the number of ions we need to make those molecules. So if it was just H plus going to H, we'd already have one H on both sides of our equation, whereas now we're going to need to balance the two H pluses so that we can make H2 and two Cl minuses so that we can make Cl2. Now there will be arrows in here, and I would suggest putting equations together like this, whereby you leave yourself space, sort of on the left hand side before the arrow, and then obviously you've got space on the right hand side after the atoms, or in these cases the molecules that we're going to form. And in there we can pop our electrons. So when we're thinking about half equations, they must always contain electrons, and they're only showing what's going on in half of the process. So in one test tube we're going to get one of these gases formed, and in the other test tube we're going to get the other. And if we're looking at them in isolation, then we're thinking about half of the electrolysis process, we're thinking about half equations. So they will always have electrons in. Now, one of the things that students can find really tricky is to think about whether electrons are going to need to be gained or whether electrons are going to need to be lost. And there's a couple of ways that we can think about this, and you will obviously choose to do this in whichever way feels easier for you. So one of the ways that we can do it is by knowing that these half equations need to be balanced, not just in terms of the atoms, but also in terms of their charges. So because we now have two H plus ions on the left hand side, the overall charge on this left hand side at the moment is +2, whereas atoms don't have a charge. So the charge on the right hand side is currently 0. Now if I have negative electrons that I need to put either on the left or the right hand side, if I added them to the right hand side, the 0 charge would become negative, but this side is positive. So the electrons are going to have to go on this left hand side so that we have two positives, and then if we add two negative electrons, then that will make 0, which matches the charge on the right hand side. So we're going to need two electrons in there like that. And because those electrons are being gained, if we use the mnemonic oil rig, oxidation is loss of electrons, reduction is gain of electrons, then those hydrogen ions are being reduced because they are gaining electrons to become H2. The other way that we can look at that is to think about, well, how did this hydrogen ion get formed in the first place? And then we do the reverse of that to turn it back into an atom. So hydrogen atoms have one electron only. They have one as their atomic number, so one proton, and as an atom they therefore have one electron. If we've then formed a H plus ion, that electron has been lost to make that H plus ion. So therefore, if we're going back to an atom, it needs to gain that electron back again. And because there's two H pluses, we're going to need a total of 2 electrons to be gained. So that's the other way that you might want to do it. And maybe using electron configurations will be helpful for that. So hydrogen would be just one as an atom. And then if it loses one, it doesn't have any electrons. So we're going from 1 to 0 when we make the ion. So then we'd be going back from 0 to 1. So it's got to gain that one back. That probably will make more sense with the chlorine one in a second. So that's the other way you can do it. Thinking about the charges, getting the charges on both sides balanced, or thinking about how do we go from an atom to an ion in the first place and then reversing the process. Another thing that you can remember is that the cations will always gain. So reduction will always take place with the cations. And the anions, the negatively charged ions, they will always lose electrons, so oxidation will always occur for these ones. You can also remember that just to help you in case you do get confused in an exam scenario. Okay, so where do we put the electrons in this second half equation? Well, we've got two negative charges here from these Cl minus ions, and again on the right hand side the chlorine atoms as they are now don't have any charge. So we've got a -2 charge and a 0 charge, and we want to add negative electrons somewhere. So if we were to put the negative electrons here this time, that's going to make the left side more negative, and this is still going to be neutral, so that's not going to balance out my charges. So I'm going to have to put the electrons on this side so that we have 2 negatives on the left side, and then we have 2 negatives from the 2 electrons on the right side, like that. So that's the balancing the charges method. For thinking about the atoms and their electron configurations, chlorine as an atom will be 2, 8, 7, and it's the 7 in the outer shell that's important. When it becomes an ion, it gains an electron to take it to 8. So in forming the ion in the first place, we were at 7 in the outer shell, we gained 1 to make 8. So if we're then going back to an atom, we need to go back down to 7. So we need to take 1 off. And then because we've got 2 of those ions, we need to take 2 of them off in total. So those are our ionic half equations, and those are hard. And if anyone would like me to do more videos just on these half equations, again, let me know in the comments, because I'm very happy to do that. In terms of how this then helps us to figure out which is gas X and which is gas Y, we need to look at these charges here. So again, because the electrons are negative, the electrons will be attracted to here, and then they'll be discharged away from that negative charge. So if we know that gas X is going to be losing electrons, and those electrons will then flow around here, the electrons will then come down this electrode, and then they can be gained from the ions on this side. So this is where knowing which is losing electrons and which is gaining electrons is helpful. So gas X is going to be the chlorine, because the chloride ions will move to this electrode here. They'll give up their electrons, and then the chlorine gas will be made. Those electrons will then move down the electrode through the electrical wire and then across to the other side, where the H+ ions in the solution will come to the electrode, pick up those electrons, and then form hydrogen. So gas Y is therefore hydrogen. So yeah, I guess in this question it does say use the ionic half equations to identify gas X and Y, or X and Y. But even if it had said the other way, identify gas X and Y, use ionic half equations to help you, or to support your answer, or to explain your reasoning, don't be afraid to do the equations before you identify what those substances are. In the mark scheme, I'm pretty sure it gives you this part first and then gives you the half equations, but I think these are really helpful for working out this. So that's the question on electrolysis, where we're thinking about a solution, which is tricky when we are having to work out which gas is being formed in which test tube, which is tricky, and we're having to write ionic half equations, which is tricky. So hopefully that's been useful, but like I say, it will take practice, and if anybody wants me to do more videos like this, please just let me know. Thanks guys!